All right, thanks for tuning in. We are going to get started on our next lecture, which is lecture number 5. And in this unit, we're going to be talking about lipids, which is another word for fat. So we'll be talking about the chemical composition of lipids, kind of some of the negative issues associated with a high-fat diet, and look into what the functions are associated with the use of lipids, or kind of why we need them in our regular diet. So first, to kind of kick us off, when we think about dietary fats or the fat that we consume within our normal meals, dietary fat is a nutrient of the greatest concern by the American Heart Association, because a high-fat diet or the consumption, of a lot of fat is also associated with certain types of coronary heart disease, and several other chronic conditions that we want to prevent. Also, a high-fat diet, because fat is high in calories, it'll also put us at risk for issues such as obesity, which can also then lead to type 2 diabetes, hypertension, and some of those other chronic diseases that we've previously talked about in class. When we think about dietary fat as it relates to sports or exercise, dietary fat can serve as an important energy source for us in endurance types of sport events, so long as those events are greater than 45 to 60 minutes in duration. We can get a substantial amount of our energy expenditure coming from fats. So when we think about the types of dietary fats, so what are the types of fats that I can consume in my average regular diet? Certainly triglycerides are kind of the most common way for us to consume fats. And again, we'll take a look at what a triglyceride looks like. But again, to review for you, tri means 3. So it's got 3 fatty acids. So it's a glycerol backbone with 3 fatty acid tails. And again, this is a very chemically stable molecule. So it's easy for us to consume in our diet, but it's also easy for us to store, fats within our bodies in this form of a triglyceride. We also consume cholesterol. Again, you've probably heard of some foods that are high in cholesterol, such as red meat and eggs are 2 examples of foods that are high in cholesterol. So we'll take a look at what that is. We also have phospholipids, which are going to be super important for us when we take a look at cell structure and some different functions within the body that way. Then we have specific fatty acids. We can have essential fatty acids, and similar to what we've talked about with essential nutrients and essential amino acids, our essential fatty acids may not be synthesized in the body, so we must obtain them in our diets. Okay, so again, if you need to get the definition down for essential fatty acids, it is a fat that may not be synthesized in the body and must be obtained in the diet. Okay. And then lastly, we get a lot of buzz for this term omega-3s, omega-6 fatty acids. You've heard about the omegas probably. So our omega-3 fatty acids are polyunsaturated fatty acids that have a double bond between the 3rd and the 4th carbon. You don't need to know that, but when we look at their chemical setup, that's what it kind of looks like. But again, the reason that omegas get a lot of attention is we believe that consuming these fats, which we consider to be a healthy version of fat, they are theorized to help prevent coronary heart disease. They also could potentially help us with reduction of inflammation, which is also a good thing when we think about not only sports performance, but also just our general health as well. So again, when we think about the common properties that we see when we are consuming fats, humans actually need very little fat in their diet in order to maintain good health. So we can intake as little as about 10% of our total calories from fats. And the nice thing about fats is that if we overconsume any other nutrient, so if we overconsume alcohol or carbohydrates or proteins, we can convert all of those different chemical configurations, we can convert those into fats. Again, so we really don't need a whole lot of fat in our average everyday diet, just simply because we can get them from other places. The recommendation when we think about how much fat we need, again, we want a minimum of 10%, but the recommendation is really up to 35% of our total calories. And we want to emphasize minimizing the amount of saturated fats and trans fats that we're consuming. So what are some of the common properties that we see when looking at a fat molecule? So again, we said that triglycerides were the most common type of lipids, and we said tri means three, so they have three fatty acid tails and a glycerol backbone. Other kind of interesting things about, or unique things that we see as it relates to fats or lipids, they don't readily dissolve in water, and this is called being hydrophobic. Hydro means water. Phobic, if you think about a phobia, it's like you're scared of something. So phobia means to be scared. Hydro means water. So hydrophobic molecules are water fearing, or they're afraid of water. And so as a result, when they are submerged in water, they tend to cling to each other, which is why, like, if you put oil and water together, you'll see like little chunks of oil separating themselves from the water molecules. And again, that's kind of their way of protecting themselves because they're fearing of that water. They don't want to dissolve or mix well into the water. We have liquid lipids that can come in the form of oils. Again, generally these are coming from plant products, and generally these will contain unsaturated fatty acids. So again, when we think about liquid fats or oils, they're going to come from plants, and generally they are high in unsaturated fats. Okay. And when we think about solid lipids, these fats usually come from animals. And if they are solid in nature, we would assume that they have quite a bit of saturated fat in them because each of those chemical bonds is going to be saturated with a hydrogen molecule. Okay, so again, to kind of review on this side, liquid lipids are going to be high in unsaturated fat. Solid lipids are going to be high in saturated fatty acids. Okay. When we think about triglycerides or fats within our body, fats can be stored in essentially three locations internally. So number one, probably the place of the greatest amount of fat storage within the body is our adipose tissue. Okay. Adipose tissue is the same thing as like your fat cells or your fat tissue. Okay. So we have adipose tissue like all over the place. For example, we have fat cells located under the skin surface. We have some that are located around the muscles. We've kind of got them a little bit of everywhere. So adipose tissue is kind of our number one location for us to store fats. Okay. Number two, fats can be stored within the liver. Again, if you remember back to our carbohydrate unit, you learned that the liver is a location where we're going to have a lot of processing going on. So we were processing our simple sugars or our monosaccharides there. We're also going to process some of our fat molecules there as well. So it sounds like a great place for us to also have some fat stored. So adipose tissue is number one. Number two is in the liver. And number three, the last location for fat storage is in the skeletal muscle or between the muscle cells. Again, I kind of have like a weird example of, how we know this to be true. If you think about like chicken and consuming chicken, you have like your dark meat and your white meat. So the white meat comes from the breast of the chicken. And again, if you think about what the animal needs to do to survive, they don't really use their breast muscles because they're not really flying, or if they are flying, they're not flying very much or very far. So they're not using those breast muscles very much. So therefore, that meat is white. And one of the reasons why it's white is because it doesn't contain much fat in it. Okay, so there's not a whole lot of fat stored in there. Now, if you think about consuming the thigh of a chicken, for example, it's known as dark meat. And the dark meat, in my opinion, and again, if we were in class, I would ask you your opinion as well, but I think the thigh and the leg of a chicken tastes really good. So I like the taste of dark meat. And again, the reason that a lot of people like that taste is because it's fattier. Okay. And again, if you think about what a chicken does in order to survive or move throughout their normal day, they're using their legs and their thighs in order to move. Okay. And again, if we also think about the function, I'm kind of getting a little bit ahead of myself here, but one of the functions of fat is to serve as a fuel for kind of low intensity activity. And so for a chicken, walking around or running around or whatever is their form of activity or exercise. So it makes sense for them to have a lot of fat stored within those particular muscles, in their thigh and leg muscles, because they're going to utilize that from their day to day in order to move around and things like that. So again, I know that's like a weird example, but that just kind of shows you the difference of fat storage when we look at location of muscle. Again, if we were to look at a human and where they're storing fat, a lot of it would have to do with what are they doing. If we looked at a long distance runner, we would probably see something similar to what we would see in that chicken. Maybe their legs or their lower extremities are going to be high in fat storage within the muscles. Maybe their upper extremities aren't going to have as much fat stored. So again, this can vary from location to location, but at the end of the day, we do know that we are storing some fats within skeletal muscle, regardless of who you are. When we think about, the amount of fat stored either in the adipose tissue or in the liver or in the skeletal muscle, depends a lot on many variables. So this can be pretty variant. Again, you can understand that the amount of fat that you have stored has to do with, what you're eating regularly, how much activity are you doing, and then certainly genetics will play a role as well. Our liver fat storage is pretty similar across a variety of types of people. So again, there's not a whole lot we can do to modify the amount of fat we have stored in our liver. And then again, within the muscle, this can be modified depending on activity level. So again, somebody that's an endurance athlete might have more fat stored in the muscles that they're utilizing for those endurance activities in comparison to, somebody who's not an endurance athlete. We wouldn't expect to see a whole lot of fat stored in like some of our high power athletes. So like a football player or a baseball player, softball player, for example, we wouldn't probably have as much fat stored inside of the muscles. And again, when we think about those energy systems, if I'm doing high intensity, high power movements, then I'm not using fat as a fuel. So it doesn't really do me any good to have fat located within the muscle in that particular scenario. So again, when we think about fatty acids, again, it's a carbon chain with hydrogen bonds. So again, we have hydrogen ions that are bonded to the carbon chain. And when we look at the differences between saturated, monounsaturated, polyunsaturated, and trans fat, I've got an image on the next slide that can kind of show us the difference between what these look like. Again, when we think about, what we're consuming in our diet, a lot of times it's easy for us to say like, oh, animal products, that's saturated fat. Plant products, that's unsaturated fat. And that's kind of true, but in reality, we're getting a little bit of everything. So dietary fat is made up of a mixture of different amounts of fatty acids. So again, an animal product might have 80% saturated, but they're still going to have some unsaturated fatty acids, and then vice versa. So again, if we look at something like olive oil, for example, it would have quite a bit of unsaturated fat, maybe like 60% or something like that, but we're still going to have some saturated fats as well. Okay, so here you can see two different chemical configurations. So again, here you can see the carbon bonds up here. And then notice that each carbon needs to have kind of like 4 little bonds, basically. And in the saturated version, each bond is saturated with a molecule. Okay. And again, notice that in the saturated version, there are more H molecules than in the unsaturated version. Okay. And this is one of the reasons why saturated fats are going to be more solid in nature in comparison to unsaturated, which is going to be more liquid in nature, because these unsaturated fats have more room to move. So the unsaturated fats can be a little bit more mobile, and so therefore these are more likely to be liquid in nature. Whereas our unsaturated fats, because everything's kind of like crowded, basically, because each of these bonds is filled, then it's going to be more solid in nature. So again, saturated fats have single bonds. They only have single bonds, and each single bond is filled with a molecule. And because each bond is filled, the molecule is very like crowded. You could think of it that way. It's very crowded within this molecule, so therefore it's more solid in nature. It's hard for these guys to move around because they're kind of like crowded in there. Okay. Whereas with unsaturated fats, we have at least one double bond, and this double bond basically means that each of those bonds was not filled, so they weren't saturated, so they weren't filled up with these H molecules. Okay, so again, unsaturated needs at least one double bond, and that's going to allow this type of fat to be more liquid in nature because, again, check out all this space that these molecules have. Now they can move a little bit easier, which means that they are going to be a little more mobile and more likely to be liquid in nature. Again, each of these with all the C's on it is the fatty acid tail, and then the glycerol backbone that we talked about would be over here on this side in this kind of like maroonish color. Okay. Again, when we think about, kind of adding on to this idea of these unsaturated fats, I wanted to take a look at the difference between polyunsaturated and monounsaturated. So on the previous slide, you saw there was one set of a double bond. Okay, mono means one, so a monounsaturated fatty acid will have one double bond. Polyunsaturated fats, poly means many, so a polyunsaturated fatty acid will have many double bonds. Okay, so here you can see 3 double bonds here. So it's a polyunsaturated fatty acid. Okay, the more double bonds that there are, the healthier we consider this molecule to be. Okay. Essentially, again, this is a pretty simplistic way to think about it, but like the more H molecules that you have, the more energy you get. Okay, so again, it's saturated fat's going to be like super energy dense because it has a lot of these H molecules. Okay, an unsaturated fat, because I'm missing some of those H molecules, it has a little less energy in it, so therefore it's a little bit less dense. It's a little bit healthier. You can think of it that way. When we look at trans fats, again, trans fats get a lot of attention as being kind of a bad guy. And basically what we do with trans fat is we take something like this. We're going to take a polyunsaturated fat and we are going to chemically inject it with H molecules. Okay, so we're going to chemically inject this configuration with these two extra H molecules that they didn't have down here. And the reason we're going to do that is because it allows us to take this molecule, which we said was like super liquidy, and it allows us to convert this molecule into something more solid in nature. So again, when we think about margarine and different types of substitute products for like butter, again, we're going to take, a lot of times, we're going to take things like this polyunsaturated fatty acid, which would be liquid otherwise, and we're going to inject it with hydrogen molecules, and that's going to allow us to make this product more solid in nature, which is what I want if I want something like a butter or a margarine, something along those lines. Okay. The issue with this chemical modification is that we know that these are detrimental to our health because we've modified this from a chemical standpoint. So again, one of the dietary recommendations that we'll talk about in this particular unit is limiting the amount of trans fats that we are consuming because, again, they're not as natural. We wouldn't consider them as healthy as this version of the fats. Again, as we mentioned, we kind of make this generalization that animal products are saturated fats and plant products are unsaturated fats. And that's a good generalization, but again, not completely true. So check this out here. So let's take a look at the difference between, some animal versus plant products to get a good understanding of the composition of what's going on. Again, I'm not going to test you on these by any means, but it's a nice way for us to see what's actually inside of each of these products. So let's take a look at olive oil, for example. Olive oil has about 75% of monounsaturated fats. Again, we would prefer to consume unsaturated fats as opposed to saturated fats. And notice that it's got about 15% of saturated fats. Okay, if we move down here to like a beef product, again, notice that we're about 50% saturated and about 50% unsaturated. When we look at lard, which is also going to come from an animal product, notice that we're like 43% saturated and 47% unsaturated. Okay. Again, there's always exceptions to this rule. We think about coconut oil, and coconut oil is supposed to be super healthy. And notice that it's got 91% saturated fat and about 7% unsaturated fat. So it's kind of interesting to see that this is really the outlier when we think about animal versus plant products being saturated versus unsaturated. So again, as a good general rule, the majority of fats in plant products are going to be unsaturated or polyunsaturated in nature. And when we think about animal products, they're going to be more likely to have a high amount of saturated fat in comparison to unsaturated. Again, what's the big deal about fats? Why are they so bad? Foods with the highest energy density are high in fats and oils. So again, here are just a couple examples of high fat foods. When we think about the calorie content of fats, 1 gram of fats has 9 calories. In comparison to carbohydrates, we had 1 gram of carbohydrates was equal to 4 calories. And the same is true with protein. So protein, 1 gram of protein is equivalent to 4 calories. So again, fats are more than double the energy density in comparison to, our proteins or carbohydrates. Okay, so it's easy for us to understand that foods that are high in fat are also going to be high in calories as well. So again, something like mayonnaise, you have one serving or like one tablespoon of mayonnaise is like over 100 calories, which isn't really a whole lot. Peanut butter, same thing. One serving can be like 200 calories easily. Again, a lot of these are unhealthy, but there are some healthier high fat things on this list here. So for example, walnuts, all the nuts actually are super dense in calories. So again, a lot of times if people are interested in gaining weight or having a hard time, getting enough calories in, I always recommend things like almonds, cashews, walnuts, any of those nuts are going to be high in calories but low in like volume. So again, like a handful of walnuts, a small handful of walnuts is easily 200 calories. Avocado, again, another healthy option for us in terms of foods that are high in fat. Again, avocados are going to be high in those polyunsaturated fats, which we said were the good fats. Again, one avocado, I don't know if you'd ever eat a full avocado, but again, easily over 200 calories just for one avocado there. So again, a couple different examples of healthy fats. So avocados, the walnuts, the eggs, those are all good choices. The rest of these are delicious, but not as healthy, but very high in calories when we think about the actual serving size. So again, for like dressing, salad dressing, that sort of thing. Easy to get 200 calories of salad dressing on a salad, or, using that to like dip your carrots in, or like your chicken strips or whatever. It's easy to get a lot of calories in that dipping because they're so energy dense. Okay. Again, when we talk about our saturated fatty acids, animal fats contain about 60% saturated fats. And again, the kind of issue with consuming a lot of animal fats is we do know that there's a link between consuming a lot of saturated fat and high cholesterol and cardiovascular disease. It can also increase our risk of blood clotting, and we'll talk about that coming up at the end of this unit when we talk about the digestive process associated with fats and why that can be problematic for us consuming a high amount of these saturated fats. So again, it's important for us to try to limit the amount of saturated fats that we're consuming because we see a link between general health or our risk of cardiovascular disease and a high consumption of these particular types of nutrients. Again, unsaturated fatty acids contain somewhere, between 75 to 95% of their fats coming from an unsaturated form. Again, we said that unsaturated version was going to be a healthier option for us. So when we think about, trying to meet that guideline, how much fat should we consume in a day, we want to try to focus on getting some of these healthier fat options as opposed to some of those plant or some of those animal products. Okay. One thing that's a little bit, I think, tricky for some people is this idea of reduced fat or no fat foods. Certainly, we've already talked in a great amount of detail in this unit so far about why saturated fat is bad and how it can lead to, some chronic diseases and things like that, put us at a higher risk. But we haven't talked about this idea of reduced fat. So many manufacturers have introduced reduced fat versions of products as a healthier alternative. Again, fat content of these products, in order for us to say reduced fat, they have to have, I think it's either, I can't remember off the top of my head, I believe it's 25% less of the original fat content in that particular product. Okay. But the tricky part when we think about these reduced fat foods is a lot of times the energy content of that product isn't substantially lower. Okay. So generally if fat is reduced, we put sugar in its place in order to like substitute for that basically. So that can be problematic when we think about total amount of calories in versus calories out. So let's take a look at this. I've got a example here on the next slide of what the nutrients might look like in a reduced fat versus a regular fat version. Okay, so here you can see on the left side, this is your standard version. I believe this was for yogurt, I think. So again, a half a cup of yogurt, we had 100 calories in the product. You were getting 4 grams of fat, you were getting 8 grams of protein, and you were getting 8 grams of carbohydrates. Now on the right side, you can see the reduced fat or the fat-free version of the same product. And notice that it's actually 50 calories more than what your regular version was. Okay, so you've actually got more calories here. We're consuming 0 grams of fat, but now instead of 8 grams of carbohydrates, I'm consuming 30 grams of carbohydrates. So again, basically all we did was we took out the fat and we put sugar in its place. Protein stays equivalent or the same. Again, when we think about which of these is better for you, what's a better product, yes, I think it's important for us to pay attention to how much fat we're consuming, but at the end of the day, we've got to think about calories in versus calories out, right? So again, if I have been regularly consuming this product, let's say I have yogurt every day, and now I switch to this version, and so I'm consuming 50 extra calories every day because I've switched to this non-fat version, right? That can be problematic because now, I'm over consuming 350 calories a week. So, over the course of several weeks, I'm going to gain weight just because I'm eating this non-fat version as opposed to the original version, which was actually lower in calories. So, I think it's really important for us to actually look at these nutrition labels and take a look and see, is that reduced fat version actually any better? Again, from a calorie standpoint, it's usually not substantially different. Again, it could even be this dramatic. It could be more than that which we saw with the regular version. So again, something to kind of keep our eyes on. So when we think about lipids and what the functions are, so again, we've talked about kind of minimizing the amount of lipids that we're consuming, but we said we also want to keep our intake above at least 10% of our total calories. So when we think about functions, 4 major functions for us. Number 1 function is to provide us with energy for the body. So again, fats can serve as a substantial contributor to energy metabolism. So number 1, provide energy for the body. Number 2 function, so again, when we think about why fats are important for us, they're very chemically stable. So fats are very easy for us to store. So function number 2 is storing energy for later use. Number 2, storing energy for later use. And again, this is important for us because when we think about, like survival, people had to go or have fat stored so that they could survive for a day if they didn't have food. If they ran out of food, they couldn't find food. If they were hunters, gatherers, etc. So they had to have some fat stored as kind of a backup. So storing energy for later use is important for us. Okay. Function number 3 is insulating and protecting the body. Okay, so insulating and protecting the body. So fats can be stored under the skin surface, and that'll serve as an insulator for us to help us kind of maintain our body heat. Even just a small amount of fat underneath the skin surface is an effective way for us to keep the heat in our body when needed. And also protection of the body as well. So again, we have fat kind of located around various organs, and that can help us to serve as a shock absorber of our vital organs. So again, it prevents them from running into each other and jiggling around in there. So insulating and protecting the body is an important function for the lipids. And then lastly, transporting fat-soluble vitamins. Okay, so we have 4 different fat-soluble vitamins, which we will talk about, but they have to be carried with a fat molecule. So in order for us to absorb and utilize those vitamins, we need to have fat available. Okay. So again, to review the functions, function number 1, provide energy for the body. Number 2, storing energy for later use. Number 3, insulating and protecting the body. And number 4, transporting fat-soluble vitamins. Now keep in mind, as we've previously mentioned, that overconsumption of any other fuel, so carbohydrates or proteins or alcohol, those fuels can be converted into fats. So it's not like, oh, I had a bunch of protein, I'm just going to pee it out. No, it's going to be converted into fat, and we're going to store it as fat. Okay, so we've got to watch consumption. Total calorie consumption most certainly is important for us to keep in mind. Okay. So when we think about providing energy for the body, triglycerides are our main fuel source in 3 different scenarios. Number 1, they're our main fuel source for the muscles while we're at rest. So again, we're going to use approximately 60% of our total metabolism while at rest is coming from fats. Again, we could use indirect calorimetry to find out exactly how much fats we're using while we're at rest. But as a good general rule, it is the main source of fuel for our muscles while we're at rest. Again, keep in mind that that's not a whole lot of calories. Like, we're not burning a whole lot of calories just sitting here doing nothing. But we are getting those calories primarily from fat. Okay? Number 2, it's also our main source of fuel during low intensity activity or light intensity activity. So during light activity, we will use fat as a fuel source. Again, it's important for us to note that in order for us to kind of fully activate our fat burning pathways, we have to do that activity for a minimum of 30 minutes before we even activate those pathways. So again, when we think about light or low intensity activity, we need to do 30 to 45 minutes of that activity in order for us to mobilize or activate those pathways. And then lastly, triglycerides will serve as our main fuel for endurance exercise greater than 60 to 90 minutes. So again, as the duration of the exercise continues, also the reliance on fat as a fuel source will also increase. Okay, so again, to review this slide, number 1, it's our main fuel for muscles while we're at rest. It's our main fuel during low intensity activity. And it's our main fuel source during endurance exercise greater than 60 to 90 minutes. I think we'll do one more slide here. So again, when we think about storing energy for later use, we think about, these functions that we're kind of going through. Storing energy for later use, our body's ability to store fat is essentially limitless. I think we know that if we can just take a look around in our country at the levels of obesity that we have and the number or the prevalence of obesity within our country. So again, our body is very good at storing fat. It's a very chemically stable molecule, so therefore it's super easy for us to convert things to fat and store them that way. Our adipose tissues our adipose cells can increase by about 50 times in weight. So one thing that's kind of cool is once you're an adult, basically, we don't believe that you can increase or decrease the number of fat cells that you have. Okay, so you have this certain number of fat cells, and that's what you have. So when you lose weight or you gain weight, we're not gaining or losing cells. We're just going to increase or decrease how much we have stored within a particular cell. So an adipose cell can increase by 50 times in weight. So again, when we think about people that have, extreme obesity, their cells are really, really big. They're really stretched out because they're able to store a lot of fat within one particular cell. Whereas someone that's thin or has, a low amount of fat stored, again, they maybe have the same amount of adipose cells, but they don't have very much fat stored in each individual cell. Okay. Again, as mentioned, triglycerides are a very chemically stable molecule, so therefore it's a super safe way for us to store energy, and so our body enjoys storing energy that way. And again, when we think about these adipose cells, they contain about 80% lipid and 20% water. So again, they don't require a whole lot of water weight in order for us to store fat in this particular way. Not in comparison to muscle. Like muscle has to store a lot of water. And again, that's one of the reasons why people that have a large amount of muscle mass, it's like, I don't want to say it's harder, but they need to consume more water in order to maintain the water weight that they store within their muscles versus people that have a large amount of fat. They don't have to store very much water. So anyway, I think we'll stop there for today. I hope you have a great day, and we will see you on Friday. So lipids will be really important for insulating and protecting the body, and they will be important for what's known as subcutaneous fat. And subcutaneous fat is fat that's going to lie under our skin surface. We have fat tissue that surrounds and protects our internal organs as well. So that's going to be fat that's known as visceral fat, and that's going to be like more internal in nature. This makes up what's known as our essential fat. And essential fat is fat that we need in order for us to maintain our normal physiological functioning. So it's going to allow us to maintain that normal functioning within the body. And our essential fat levels for males are around 3 to 6%, and essential fat levels for females are going to be around 10 to 13%. Fats are also going to be important for transporting fat-soluble vitamins, and we have triglycerides that can carry fat-soluble vitamins to the small intestines and aid in their absorption, and our fat-soluble vitamins are E, D, A, and K. Okay, so our fat-soluble vitamins are E, D, A, and K. Fats are also going to be important in creating cell membranes, and a cell membrane is just like the boundary or the border of each particular cell. And these cell membranes are going to be made of phospholipids. And so a phospholipid, you can kind of see here from its chemical breakdown, is going to be made up of a phosphate group on the top, and then fatty acid chains in the middle here. Okay, so fats are going to play an important role in creating normal, healthy phospholipids or cell membranes. Okay, so this is kind of cool. So this kind of shows you what those cell membranes might look like. So you can see each phospholipid is going to kind of face in. So it's a double layer, and the phosphate group is going to be on like the outside and inside. So those are going to be interfacing. And then the fatty acid tails are going to be kind of smushed together, hiding together on the inside of the cell membrane. Fats are also important for cholesterol in the body, and cholesterol is going to help us to form some hormones such as testosterone and estrogen. They'll also play important roles in creating building blocks for bile salts, and bile salts are going to be important for the breakdown or digestion of fats. There are also essential structural components of cells, so cholesterol will play an important role in creating, elements within the cell. They'll play an important role in transporting lipids to the blood or through the blood. And also another kind of fun fact about cholesterol, some of the cholesterol we can make inside of our body or endogenously, so we can produce it inside. And then we get about a third of this cholesterol from the foods that we eat. And again, cholesterol is going to be generally accompanied with like fattier foods or in fattier substances. So this kind of shows you some normal cholesterol levels, and cholesterol can be broken down into a couple different subcategories. So on the far left, you can see our total cholesterol levels, and ideally we want our total cholesterol numbers to be less than 200. Next, you can see what's known as LDL cholesterol, and LDL cholesterol is like our unhealthy cholesterol, and we would like our unhealthy cholesterol to be low. So we want to have a low amount of this, ideally less than 120 is kind of the ideal amount of LDL cholesterol. And the reason we don't want a lot of LDL cholesterol is LDL's job is to take fats and put it into storage for us. So we don't want to be able to like store too much fats. And so that's why we want to keep those LDL levels low. HDL, or our healthy cholesterol, we'd like that to be above 60, and healthy cholesterol, or HDL levels, their function is to take fats out of storage and carry it to the muscle so that we can use it. So we'd like to have high HDL levels. That would tell us that we're good at burning fats and good at utilizing fats. Okay, then you can also look at triglycerides within the blood as well. And again, we don't want this to be very high. Triglycerides are very sticky, so we don't want a lot of sticky fats within the blood substance, because that's going to cause the fat to potentially like get stuck on the walls of the vessel, which can lead to like a blockage, which would lead to like stroke, or it could lead to like cardiac event as well. So again, we want to kind of keep those triglycerides low in addition to our total cholesterol. So what are the recommendations as it relates to fat intake? Okay, so it's recommended that fat intake accounts for 25 to 35% of our total calories, with a small amount coming from saturated and trans fat, and with us kind of focusing more on those unsaturated fats as our primary fat source. Cholesterol intake could be 200 to 300 milligrams per day, and AHA, which is the American Heart Association, recommends that high-risk individuals should reduce fat intake below that 25 to 35%. High-risk individuals are people that are maybe more susceptible for heart attacks and some of those chronic cardiovascular diseases. So again, we want to kind of watch that fat intake so that we can potentially prevent those things. So problems with excessive dietary fat. So from a health perspective, again, too much fat is going to put us at risk for cardiovascular disease, obesity, type 2 diabetes, certain types of cancers. So again, it's going to put us at risk for a lot of potential health problems. So we want to avoid too much fat, because it's also going to be very high in calories in comparison to the other nutrients. So, it's easy for us to overconsume fat if we are consuming it would be easy for us to overconsume calories, because fat contains quite a few calories per gram. From a sport perspective, again, high amounts of dietary fat can lead to GI distress and can lead to issues there. Again, if I'm doing some sort of sport or exercise, my primary fuel source is going to be sugars or carbohydrates. So it would be more important for us to kind of focus in on consuming appropriate amounts or more carbohydrates, and kind of minimizing the amount of fats that we are consuming. What are the dietary fats and cholesterol health implications? So chronic diseases associated with excessive dietary fat include coronary heart disease, obesity, diabetes, high blood pressures, certain forms of cancers. Avoid diets that are very low. Again, we really want to kind of focus on moderation, and making sure we're focusing on healthy fats as well, such as like avocados and olive oils. Those would be good options for us in terms of good, healthy fat sources. Okay, so let's take a look at fat digestion and absorption, and kind of how this works from a physiological perspective. So again, we're kind of going through the same process that we talked about with carbohydrates, starting with what happens with the fats as we put them into our mouths, and kind of moving through each of those digestive locations until we get to our final destination. Okay, so we'll start with the mouth, where we're consuming these calories. Little fat digestion will occur in the mouth. The food will move then from the mouth through the esophagus and into the stomach. In the stomach, we are going to release a substance known as gastric lipase, and gastric lipase is going to allow us to break down the triglycerides, which is our kind of our most basic form of fats, into smaller nutrients. Okay, so again, it's going to allow us to break that triglyceride down a little bit to smaller, like smaller fragments. Then we have bile from the gallbladder and other enzymes that are going to be released in the small intestines. And again, this will help us to also break down those triglycerides. Okay. Fat absorption. So in the small intestines, we have short and medium chain fatty acids that are going to travel through the intestinal wall through a process known as passive diffusion. And our short and medium chain fatty acids are then going to travel through the portal vein or the hepatic portal system into the liver. So again, that was the same pathway that the carbohydrates took once they went through their absorptive processes. And so we'll do the same thing with our short and medium chain fatty acids. Long chain fatty acids are going to form micelles, which are tiny bubbles that surround and carry fats across the membrane. And these are going to enter directly into the circulation through the lymphatic system. So we'll take those long chain fatty acids and they're going to dump directly into the blood, which isn't great because, that's going to put us at risk for those fats kind of sticking to the walls of the vessels, which we already mentioned can lead to some potential concerns along the way. So again, from a lymphatic system, dumping those fats directly into the blood isn't really great in terms of our general health, but that's kind of what we do. So diffusion, again, we said that these fats are going to move through passive diffusion. And here you can see that process where we're going to move from an area of high concentration to an area of low concentration across the membrane layer. Again, this doesn't cost us anything, but can be a little bit slow, which is why we would want to avoid fats if we're doing exercise, because the process of fat absorption is going to be a little bit longer. Okay, here you can see what happens with those long chain fatty acids. So again, we're going to put them into something known as a micelle, and the micelle is kind of like a little backpack, and then they are going to cross over the membrane wall and enter into the lymphatic system, where eventually they will dump directly into the bloodstream. Okay. So long chain fatty acids are going to combine with a protein carrier and form what's known as a lipoprotein once they're inside the intestinal wall. Okay, once they leave that intestinal wall, they're called chylomicrons, and those chylomicrons are going to be carried into the lymphatic system. Once the fats reach the cell, they can be used for fuel or they can be stored within any type of cell as well. And again, we're not really particular. We can like store fat kind of anywhere, and we kind of store it, based on genetics. We'll store it in different locations, and that kind of goes into like different body types. Some of us are more likely to store it in our hips and thighs. Some are going to store more in our tummy region. A lot of that is based on our genetics. Okay. So when we think about fat metabolism, fats are broken down and used as a fuel through the process of lipolysis and beta oxidation. We can only use fats in the aerobic pathways and really only for lower intensity exercise. So during low intensity exercise, fats will account for about 80% of our calorie expenditure. But during high intensity exercise, we're going to rely more on carbohydrates, which is why it's important for us to fuel with carbohydrates if we plan to do exercise, because it's likely that we're going to get above kind of that low intensity exercise range, during that exercise bout. All right, I think that's it for today. I hope you have a great day and reach out if you have any questions.